This lesson goes along with section 9.4 in digits, and the title is Congruent Figures. We've already talked about what congruent means. It means the same size and same shape. So we are going to identify a sequence of transformations that maps one figure to another congruent figure. When a new figure is created by sliding, which we say translating in the higher level, rotating, or reflecting the original figure, then the two figures are considered congruent. And you can see in your notes that the symbol for congruent is an equal sign with a squiggle on top of it. That is the symbol for congruence, and you must know that symbol. Alright, so down here we are going to take a look at the original figures, and you can hear my dogs are playing in the background. Sorry about that. We are going to identify the transformation rule that maps the pre-image onto its image. So make sure that you can see the little tiny primes. I know it's small, but the primes, remember, are the image. So we want to go from the pre-image to the image. So the transformation, first of all, I can see that A goes over and down to get to A prime. So that's a slide or a translation. And the rule for the translation is XY goes to, and then since we went to the right 4 spaces, it's X plus 4, because X's go right and left. And then we went down 2, so it's Y minus 2. That's the rule for the translation. And you can see that triangle ABC is the same size and shape as triangle A prime, B prime, C prime. So I'm going to add in here that triangle ABC is congruent to triangle A prime, B prime, C prime. Alright, the next one is a reflection over the x-axis. So we can see here, here's the x-axis, and if I flip ABC over that line, I get A prime, B prime, C prime. So what happens is that the x's stay the same, but the y's change. So this point, A is -5, 1, and A prime is -5, -1. So the rule is XY goes to, the X stays the same, but the Y becomes the opposite, so -Y. And we can also see here that triangle ABC is the same size and shape as triangle A prime, B prime, C prime. So I'm just going to write that triangle ABC is congruent to triangle A prime, B prime, C prime. And the last one, if we draw, we can see that it's not a flip, and we can see that it's not a slide. So it must be a turn. So let's take a look at the points. A is the point 1, 3, and A prime is the point -3, 1. And if we were to draw the angle of rotation, we can see that it's a 90-degree angle of rotation. And remember that we start at the A and go to the A prime, so that means we are turning in a counterclockwise direction. So this is a 90-degree rotation counterclockwise. And if I continue looking at the points, B has the coordinates 4, 4, and B prime has the coordinates negative 4, 4. C has the coordinates 4, 1, and C prime has the coordinates negative 1, 4. And lastly, D is 1, 1 here, and D prime is negative 1, 1. So you should see a pattern where the original X here becomes the Y in the image, and the original Y becomes the opposite in the X position. So the rule for this is XY goes to, okay, so the original X became the Y, so we're going to put that over here, and the original Y was turned opposite and became the X, so it's negative Y X. And so we can see that the shapes are the same size and same shape, so I'm going to say that ABCD is congruent to A prime, B prime, C prime, and D prime. Alright, for each of these graphs, the two figures are considered congruent because they are the same size and same shape. Alright, now we're going to move on to the next set of directions. Now, those directions apply as if we were working on this in class, which we aren't, so don't worry about checking the answer key. I'm just going to walk you through these. So, for part A, we are given that the triangles are congruent right here. And we are supposed to, if you look at the directions, it says describe a sequence of rigid motions that maps triangle ABC to triangle A prime, B prime, C prime. All it's asking you to do with those words is tell me what the transformation rule is, what the transformation is and what the rule is. So if you look at this first one, I can see that A can be slid over to the right and down to get to A prime. The same thing can happen to B, over to the right and down, and then C is the same, over to the right and down. So this is a translation, and the rule is XY goes to, the X went to the right 5 times, so it's X plus 5, and it went down 6, so it's Y minus 6. For part B, I can see that D goes left and up, E goes left and up, and F goes left and up. So this is also a translation. Since it went left, we have XY goes to X minus 4, since it went left 4. And it went up 2, so it's Y plus 2. Alright. Now let's take a look at the questions below. What do you know about the relationship between triangles ABC and triangle A prime, B prime, C prime? So we know for sure since it's a translation, those two are congruent. And now I'm going to introduce a new word, which is called orientation. So orientation is how they are positioned and how we name them. So let me explain it this way. If we start at A and we move to B, we are going in that direction when I talk about naming, and then from B to C I go here. So I am moving in a counterclockwise direction. If I name this A prime and I go to B prime, I'm going in the same direction, counterclockwise, when I name them A prime, B prime, C prime. So we say, if they're in the same direction when we name them, that it has the same orientation. I'm going to move back up to the top to show you something that has different orientations. So if you take a look at triangle ABC in the middle here, so I'm looking right here, okay, and I'm looking at triangle ABC. So if I name it, it's A, B, C. So I can see that as I named it, I went clockwise. If I name A prime, B prime, C prime, I start here, I go to B prime, and then I go to C prime. You can see that I'm moving in the opposite direction, clockwise. So when we have the name A, B, C, and I go clockwise, and then its image is counterclockwise in orientation, that would mean that there had to be some kind of reflection. That's going to be very important. Let's move on to the second question down here. So, based on what I said about orientation, would you say that D, E, F, and D prime, E prime, F prime have the same orientation or opposite orientations? So, if you look at D, then E, then F, I am moving in a counterclockwise direction. D prime, E prime, F prime is also counterclockwise, so these have the same orientations. If it has different orientations, it means there's some kind of a reflection happening. The same orientation means it's a slide or a translation, or which is the same thing, or a rotation. And these are also congruent. All right, let's move on to the back side. So if you take a look at the orientation, A, B, C, D is clockwise. A prime, B prime, C prime, D prime is counterclockwise. So that means that they have different orientations, which means we have to have a reflection involved. So look at what it is reflected over. So let me get rid of my arrows here. So you can see that it's a reflection, and the line of reflection has to be right in between the image and the pre-image. So right in between those points is this line. So the line of reflection is the x-axis. So this is a reflection over the x-axis. let's take a look at part D. So A, B, C, D is clockwise. A prime, B prime, C prime, D prime is counterclockwise. So that means we have a reflection because the orientation is different. And let's see what it's reflected over. So the line of reflection has to be right in the middle of A and A prime. So if we took a look at A and A prime, right in between there is the y-axis. So this is a reflection over the y-axis. Okay, moving on to part E, look at the orientation. So A, B, C, D goes counterclockwise. A prime, B prime, C prime, D prime also goes counterclockwise. So same orientation means it can't be a reflection. So that means it has to be either a slide or a turn. And if you look at where A is, do we slide A over? If we look at how it slid, A goes over and down like that. C does not go the same length over and down. So this is not a slide, which means it's a turn. So to figure out the turn, we connect A to the origin. I'll do a better job of that. Oh, sorry about that. Okay, my dog just wanted to talk to you there. Alright, so we're going to connect A to the origin, to A prime, and see what kind of angle that is. So, if we are turning, now in this case it's a straight line, so it doesn't matter if we say we turn counterclockwise or clockwise, we still end up in the same spot. So you get to choose that one. So it's a rotation of 180 degrees, and it doesn't matter the direction, so I will just say clockwise. And then you have to think of where you put your pencil point to turn it, and you put it on the origin, so we say about the origin. Alright, moving on to F, we have to see if it's a slide. Now, it could be just, if we don't look at the letters, it could be a slide. But if we look at how M is slid over, it's just over 2, and L is over and down. So therefore, it is not a slide. It also could be a reflection, and it could be a turn. So let's take a look at if it's a turn. So, actually, let's look at reflection first. If it's a reflection, then M and M prime are split down the middle here, which means L should be over here if it's a reflection, but that's J prime. So the letters are extremely important to look at to know what kind of a transformation this is. So this is not a reflection. So, and the other thing we could have looked at, if we name this J, K, L, M, it goes J to K to L to M like this. So that's clockwise. And then J to K to L to M primes is also clockwise. So that tells us it's not a reflection as well. Alright, so it must be a rotation. So to find the angle of rotation, we take a point. Let's take the point L, connect it to the origin, and then to L prime. So we are going from L to the origin to L prime, and I am going in this direction, so that is counterclockwise, and that's a 90-degree angle. So this is a rotation, 90 degrees, counterclockwise, and I would put my pencil point on the origin to rotate it, so it's about the origin. Now I also could say that I rotated it this way. If I do that, I could say it's a rotation of 270 degrees clockwise. So either one of those is acceptable. Okay. Sometimes it takes more than one transformation to show that two figures are congruent. So triangle JAR is congruent to LID. So you look at where J is, and you look at where L is, and those two have to go on top of each other. So we move it 4 units to the right. So we're talking about here, and down 1. And then if you take this purple figure right here, and you reflect it over the x-axis, you would get the final. Okay, so these are kind of tricky to do. We need to figure out how we can get the first shape without the primes, the pre-image, onto the image. So let's take a look at this one here. We have A going to A prime. So the first thing I'm going to do is figure out if there is a reflection involved at all, because if there is, the orientation will be opposite. So if I look at A to B to C to D, that's clockwise. A prime to B prime to C prime to D prime is counterclockwise, so I know that there has to be a reflection. Alright, so the reflection could be, we have lots of choices, but it can't be the y-axis right now. Because if it's the y-axis, then A prime would come over to here. But if I go ahead and reflect it over the y-axis, this would be A prime. B prime would be 4 units away from the y-axis. Let me draw the y-axis here in yellow. If I reflect it over that, it's 4 units away. So it would be here, B prime. C prime would be 4 units away, down here. And D prime would be 3 units away. Okay, now, that's obviously not the only thing that I have done, but if I take each one of those and I move them, right 1 and up 3, 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 I do get my final image. So that's exactly what I'm going to say happened. So the first thing that happened is that it was a reflection over the y-axis. Followed by a translation. where xy goes to x plus 1, because we went to the right one, and then y plus 3. Now the neat thing about this is that is not the only possible answer. So you could have different answers and still be correct.